That's why I stopped all of the learning we're learning, because sometimes the learning can feel too much if you're not applying it to solve problems. Right now, I believe that some of us that were able to solve problems with with the little knowledge you have. Sorry, permit me to call it little. Oh, yeah, let me call it that, because of course, according to what I taught you is little. Maybe you know so much that I didn't know you know, but I mean, what I taught you was little. But with the little we learned, I mean, with the tiny little we learned, at least we were able to build something. Now, each and every time you build a project, it adds to your confidence. That is what happens to you. Your confidence grows, your confidence increases, right? And that's why you should always try to attend, solve problems. And now, what I have done is that I have put an appetite on you to try to analyze any data set that comes to your front with the little knowledge you have. And if the only thing you were able to achieve is to analyze one data set, just the one you analyze and you presented, then you're missing it out. If I were you, I would set like a KPI for myself. Every week I must analyze two projects every week, two projects per week. If you can do that, then you find out that your growth when you go out to speak at events, you will speak with so much confidence that even people that have certifications will come and be like, okay, because you've solved projects, it's not fluff, it's not the fun stuff. You're telling people what really matters, right? So that's what building projects gives you that taking courses does not give you. I want to know, I believe that some of you, before taking this course, you've taken courses elsewhere, right? But they did not impart the building mentality in you. And that's the problem you had, right? They did not impart the building mentality in you. So what I'm trying to do, or what the team of my Analytics Data Science Academy is trying to do, is to impart into you building mentality, right? That mentality that brings you to try to build, solutions, to try to analyze any data set that comes to your front. That is what we try to do at Analytics. And I just wish, sorry about that. I wish and hope that in the end, our would I say our efforts will not be in vain. I pray and I wish so. And I also hope so that our efforts will not be in vain in the end of the day. So, like I said, what we are trying to do is to make you have building mentality. And if you learned something during your project, just give me your thumbs up. Let me see if you learned something, one or two things during your project that possibly you were even careless about. Just give me your thumbs up. Let me see if anybody learned. Okay, only one person learned. Oh. Okay, two people. I believe there are two people behind that. Okay, only three people now learned. Okay, okay. So I believe that that project has set into us the feeling that have accomplished something. And that feeling is what can make you start driving for more. You'll be like, okay, so there is more to learn. And that's why some of us are still here on this call today. They're like, okay, so there are still more things to learn. That according to your projects now that you've learned, you find out that there were some things you wanted, you maybe you should have done, maybe from the feedbacks you got from the industry experts, and also from the feedback you got during your analysis, and from also some things you would have wished you had done, but then you were not able to do, right? Those things were able to are in themselves able to help you know that there is more to learn. Like there is more to learn. So without any further ado, I'll just go ahead and share my screen so that today we'll just talk about data storytelling and visualization. That's just what we're going to be talking about today. Yeah. Let me know if you can see my screen. Kindly indicate. Okay, thank you. All right. So today we're just going to be talking about storytelling and data visualization. And of course, there are a lot of things to talk about data visualization. In fact, I might talk about some guidelines. I might give you some guidelines for doing that, but I will still not be able to exhaust them. Most of them come by practice. The more you practice them, the more you get used to them, and the more you become better you know, at them. So I'm not going to tell you that this is an exhaustive list, of the things you must do, but this, when I'm done with presenting this, it should put a quest for you. I think I will drop a book in the platform about data storytelling so that you go and read that book. Yeah, it's a book. The problem is that the book has plenty of pages. That is not the problem, really. We have a summary in slides. So I'm also going to drop the summary in slides so that you can go through it, make out time. This is yourself now. This is your brand now that you're trying to build, right? Do anything to build your brand. After you leave my analytics now, after this training, you're your property, right? If you tell anybody that you ever read anything or you took any course from analytics, nobody even, okay, let me not say nobody, we of course, by people who have come across analytics, they know us, our website is up on almost all social media, and so they can go and search us. But what I'm saying is that that is not what will give you a job. The place you came from, the place you took your training from, has little to do with whether you're going to be given a job or not. Yes, I say that. I did not say it cannot have anything to do, but it has little to do. What matters is what are you able to do. It's just that when you graduate from secondary school, some people finish private school, some people did government school. What matters is when we go to the institution that you graduate with a very, very good result. Okay, my network is cracking. Can somebody confirm that my network is cracking, please? Can someone else verify that my network is cracking? Like just drop it, just tell me yes or no, so that we know whether it's from my own end. Okay, it's not cracking. Okay, sir. I think it's from your own end, but I will just go ahead and continue. I don't know. I pray that the network gets better, though. So, like I said, it is your brand that you're building. Be very, very intentional about building it. If you decide to go and read that book or not, whether you decide to go and read it today or not, whenever I finally drop it, it is not for analytics that you're doing that. It is first for yourself. Right? When you're going there to go and look for a job, of course they will interview you. If you say you graduated from analytics, okay, so tell us this. How are we even sure you did not fabricate this certificate? Right? I know of jobs that I got, almost all of the jobs I got. I don't think it was my CV. I think it was the interview I had with the people that gave me the job, right? So I'm saying that build yourself. Know what you're supposed to put in a visual and know what is not supposed to be in a visual. Know which visual to use for this kind of analysis and which visual is not great. Know that it is a skill itself, like data visualization. But then we're going to look at it at a level that at least should get an intermediate working already. Of course, we've seen some things about data visuals already. We've seen bar plots, pie plots. That's exactly the same thing we're going to be seeing, except that this time around we're going to be seeing other plots, maybe like heat maps, maybe scatter plots. They're just box plots, of course. We're going to do that to try to, and those are things you already know, except that we did not, implement. All right. So as you can see, elevating data insights from static numbers to dynamic narratives using Matplotlib, Seaborn, and Plotly. All of these ones are visualization libraries. Matplotlib is a visualization library. The same thing that Matplotlib is doing is the same that Seaborn is doing, except that Seaborn was built on top of Mat. Let me go to the next slide so that I'm not overseeing. Yeah, so Matplotlib is the foundation of data visualization in all. These are the big three libraries when it comes to visualization. So I thought I should say this so that you understand. Matplotlib is the grandfather of all of them. Is the Oga Pata of all of the data visualization libraries we have, and then followed by Seaborn. So Seaborn was built on Matplotlib, just like you remember we said NumPy was Python. Pandas was built on top of NumPy. So Seaborn was also built on Matplotlib to give us to make visualizations very, very easy. And you find out that when we start using Seaborn, some of the things will become very, very easy for us. For example, sometimes before we plot a bar chart, we have to create like a pivot table. If you go to Seaborn, you don't have to create a pivot table, right? In Seaborn and Plotly Express, all of them. So why? And Seaborn also has some very, very deep, apart from the beautiful colors that it does have, it also has some deep statistical visuals that are not available in Matplotlib, right? Yeah. And then Plotly Express now, what it does is that it is ideal for dashboarding. It begins to show you things like sorry, hover effects, right? It begins to show you things like hover effects. They are what we call hover effects. Is when you're hovering, when you bring your mouse on top of the bar or something, you see further information on that, right? And it also gives you interactivity. That is why you need Plotly. But then you can still just learn Matplotlib and analyze your data. That's why I wanted you to see that because all of the things you've been doing is on Matplotlib. All of the ones you've been doing, that you create the value count and then you do dot plot, all what you've been doing was Matplotlib. Because if you use pandas to visualize, maybe you after a group by you add dot plot, what is working behind the scene is Matplotlib, except if you decide to change. But by default, what works behind the scene is Matplotlib. We saw a little about Seaborn. If you watched the last video I did on Castle students analysis, we did a little about Seaborn. I think we did. I don't know if it's scatterplot or something that we plot with Seaborn, but I think we use Seaborn. But we did not see Plotly.express. And all of these ones, I'm just going to be showing you how to plot few visuals with these guys. Of course, according to your hunger, go and find how to do that. Maybe subsequently, when I'm going to analyze any data, I'm going to stick with Plotly, and on some, I'm going to stick with Seaborn, so that you see how we're using all of those libraries, interchangeably. And like I said, you can only use Matplotlib, and it's okay for you. But for some visuals, maybe that Matplotlib does not have, you can now go to Seaborn. But for basic visuals that you need, Matplotlib has. And if you're okay with Seaborn, just stick with the Seaborn. And then if you feel okay, so Seaborn, I need something that is more interactive, you can now go with Plotly.express. Right? We have Plotly Go, we have Plotly Express, but we're going to stick with Plotly Express, right? So that's that. Sorry, let me just shoot this. All right, so going forward, don't worry, even if we're not able to. Oh, why is my chat missing? Okay, sorry, I'll get what to replace here. So apologies for that, but already all of us know what a pie chart is, right? So pie chart just helps us to see parts of a whole, right? It helps us to see percentages. I always use oranges as an example of pie charts, right? Where you can you can take an orange and divide it into several sections. So each of those sections is what we call parts of a whole, right? And that is what a pie chart is, from the word pie, cycle. And we also have donut charts. Donut chart is just the pie chart that has a hole inside of it. And of course, creating a pie chart, a donut chart is the same as creating a pie chart, except that you just need to pass an extra parameter that is called a hole, and then you will see that. So I don't know who will remind me. Mr. Taiwo, please remind me when we go to revisit pie chart again. Remind me so that we can when we go to revisit pie chart again, remind me so that we can plot a hole. Like I mean, we can try to see if we can get a hole inside of it so that it will look like one. So, of course, a pie chart is when to use a pie chart, it is ideal for proportions, right? That sum up to 100%, of course. If you're trying to see maybe sales by gender, some of you that do sales analysis, or you want to see the gender representation of the data sets. I mean, how many people are this gender? I mean, how many people are this gender? Then, if you have like 2 or 3 categories, it is ideal when you have 2 or 3 categories, right? 2 or 3 categories. And remember that whatever it is that you're trying to plot, the percentages will be calculated in terms of 100%, right? So it is ideal when you have only 2 or 3 categories. For example, gender, male and female, or maybe when you have, in fact, in my own class, I will strictly tell you, use only two, use pie charts when you have only 2 categories. Once it's more than two, use bar charts. But if you decide to of course, the room allows that you can use up to 3. It's still fine. And there is a reason why. It's because pie charts are delusional, right? If you're not a if you're not a person that knows numbers, once we have 3 bar charts, for you to be able to compare the bar charts and see which one is bigger than the other, right, is a problem. Of course, I understand that percentages help. Of course, percentages help. But it means now that somebody has to go through the percentages. What if you're presenting to one allergy or one stakeholder that does not understand numbers or is not interested in numbers? You're trying to tell him to find out between 32% and 31.5% which one is bigger. When you have two categories that are close, that are competing with each other, it becomes a problem. So it's better when you have 2 categories. At least one can easily see which one is bigger than the other. But when you have up to 3 categories, sometimes you run away from pie charts. But read it from data storytelling, it will tell you more. I think I also read it from there. I'm not just telling you fluff, I read it from there. And so when to avoid, when you have, in fact, no greater than 5, greater than 3 categories, I will edit these notes later before I hand it over to you. And then, of course, humans struggle to compare the angles, like I said, never used for non-proportional proportional comparisons, of course. So if you want to use a, if you want to get a pie chart in Matplotlib, you just use the plt.py, right? It gives you that, or you create your pivot table and then you use the .py, right? You create a pivot table, then you use the .plot.py or .plot kind equals to pi, right? You can use that. Or you can use plt.py, then you pass in the group by you did, and the other informations. If you're going for Plotly Express, of course, you just use px. We import Plotly Express as px. So you use px as pi. So this px is just a name we import plotly.express. We import it just like we do um, matplotlib, import matplotlib.pyplot as plt. That's how you also import px plotly.express as px, right? That's how you get pie charts done. Then another ones, very, very important ones are the bar charts. Very, very important, right? And bar charts are very, very important when we begin to see things, when we begin to compare categories that are greater than three, right? When they are greater than three, you have to use bar charts, especially when it is a categorical data, right? Categorical, not, you're not trying to compare two numerical features. We're going to see charts that are ideal for comparing two numerical features. But here, if you're trying to compare, if you want to see how one category is doing, with respect to other categories or another, with respect to another variable, you want to see how various categories are doing. Maybe you want to compare products and see how they are doing, how well they are being sold, or they are demanded, or they are sought after, with respect to what do you call it now? To another variable. Maybe this is the sales amount, or maybe this is the profit margin, right? We want to see the profit margin by product. If you do that, then bar charts are ideal for doing that, right? Bar charts are ideal for doing that, and they are very, very cool, like I said. And one very, very important thing is learn how to add um, your data labels. We're going to see how to do that. Very, very easy. We're going to see how to do that. How to add data labels here, how to add data labels in Seaborn, how to add data labels in Plotly. And like I told you, just know what you are expected to do. How to do it, you can Google it. As I'm talking to you now, before we do it, some of you can even Google, how do I add data labels to my bar charts in Matplotlib? And you will just see it. It's not a hard thing to do, right? But just know that you're supposed to add data labels for clarity's sake, right? And then, of course, I've already said this. And of course, we're going to see when to sort our bar plots. These are bar plots actually, and when not to sort them. When to use a bar plot and when to use a column chart, right? Remember, okay, remember we spoke about column charts. Column charts are the ones that are standing like this. And I will tell you when to use column charts, right? So column charts, bar charts are ideal when, how many of you can remember? Let me ask this question. How many of you can remember nominal data and ordinal? If you can remember, just let me know. Just put up your hands and then you can mute and talk. Yeah, yeah, go ahead. Unmute and talk, please. Okay, 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 okay. For example, sir. Yeah, just give us one rough example. I just wanted to complete what you started, but you said it well. Okay, colors, right? Colors. Yeah, of course. Except if you have some personal problem with colors, you cannot arrange colors, Abi. So colors are very, very good examples. And of course, like you said, strongly agree, agree, not sure, disagree, strongly disagree. Uh, all of those are ordinal data. But when we come to nominal, ordinal from the word order, nominal, no order. I don't even know why the name is nominal, but nominal means there is no order. So when you are using an ordinal data, like listen to me carefully. This one is not on this note. To write it if you are writing. When you are visualizing, when you are going to use a bar chart like this one now that is lying horizontally like this, right? Use a bar chart when you have a nominal data that doesn't have order, right? Use a bar chart so that you can be able to sort them by value. You can see these guys are not sorted now. You can easily sort them by value from largest to smallest, right? That is when you're allowed to even sort, right? It's only when you're using bar plots that you're allowed to sort, and when the data is nominal, so that you can sort them by by the size of their value. But when the data is ordinal, use column charts. We use column chart. That is the ones that are standing straight like this. For example, sales by month. If you want to do sales by month, please, sales by month. It doesn't have to be a line chart. It can be a bar chart. Since of course the months are categorical, but they are ordinal data because there is an order between the months. Right? They are an ordinal data. We can call them ordinal data because there is an order between the months. For example, we know that January comes before February. We don't, and we even know the number of days that are coming, even though it's not constant all throughout, right? So in that case, you use a column chart. That is the one that is standing like this. Use a column chart. And just so I will hit the nail on the head again, um, for you to know which plot to use and what time to use it, right? If you're using a column chart, now it means that the data is already having an order. That is nominal data, right? Nominal or ordinal. I don't know. Yeah, sorry, ordinal. You're using a column chart like this, right? The one that is standing like this. It means the data is already what? Is already having a natural. So we have an ordinal, that's what I call an ordinal data. So when you have that data that is already in months, you don't have to sort it by value. If you sort it by value, you create a mix-up. Because what if the best sale came in July? It means the first month will start in July, right? So they already have a natural order in them. So you don't sort them. You don't sort them. I don't know if I'm making sense though. Don't worry, if I'm not making sense, you can go back through this video and watch this one that I'm saying. This exact one that I'm saying now, right? So know when to sort and when not to sort. So understanding visuals is another word on its own. It's a course. Understanding data visualization, but it's a course on its own. And so I believe that by practice, now as I'm talking to you now, we are talking like colleagues because you have carried out a project now. You have already seen your mistakes. You already seen some of the things that if you go back now, if you have your way, you can go and change them. So if you carry out a survey where you have strongly agree, disagree, use bar charts. Sorry, use column charts, and then do not sort them. Make sure that the sorting is by the order in which the variables, I mean the categories appear. For example, let us start from strongly disagree, disagree, not sure, agree, strongly agree. That Likert scale, let it be maintained. That's how the bars should be, so that we will know where we have high concentration. Don't know if I'm making sense though, but I pray I am. Please, if I'm making sense, give me thumbs up so that I can. Okay, it's like somebody has a question. Please go ahead and ask your question. Okay, give me thumbs up, please, if you don't have questions. If you're understanding, Vivian, if you're understanding, give me thumbs up. Okay, all right. Vivian, you're not understanding. Okay, so what's your problem? Can you? Sorry, I didn't get you. Okay, your network. Don't worry, you have access to this video. I will make sure it's uploaded before the end of today. I would have even done one uploading now. Sorry, just guys, just give me a minute. I know this will part just a second. Let me just upload one video now so we can have access to it. I mean, I wanted to upload an onboarding video so that when I go home now, I will not finish. So just give me a minute. sorry, just a minute. Please don't leave the call. Oh. These things that we are sharing today, they are. I don't want to say they are diabolical, but they are things that separate amateur analysts from, you know, senior data analysts. Right? If you are a senior data analyst, it is because you understand what visual to use at what time and how to even put out the visual there. Thank God you saw there was a lot of emphasis on visualization as they were giving you feedback. Right? So it's not something you want to play with. Okay, back to our class. Um, where is it? Okay, so here we go. Now, go back on this. After bar charts, I've said a lot of things about bar charts. That's because pie charts and bar charts are the thing, most things you're going to be using in your analysis. Most. When you begin to go deeper, when you begin to have trend or time series analysis, you begin to now look at line and area charts. Right? You begin to look at line charts and area charts. And line charts is the one that you can see here. This guy here is shaded. You can see there is sign of a shading here. So when it has shading here, it's what we call an area chart. When it does not have shading, it's what we call a line chart. And that was what I showed you how to do with. Okay, I didn't show you how to plot Python syntax. You can use sns.barplot. Barplot. You can just pass in. So when you're using barplot, you can just pass in the x and the y directly without even having to do your pivot table. That is why I like Seaborn. You don't need to do your pivot table. You just need to pass in direct the names of the variable and the data set you're using. That's all. They will create the pivot table behind the scenes and plot the bar for you. But if you want to use matplotlib, you use plt.bar, of course. Then you create a pivot table. You use the pivot table that you've created. Then you pass in some other arguments, of course. And on bar charts, I've still not spoken about something like stacked bar charts and clustered bar charts. Those are not very, very difficult things. When I come to do the hands-on, we're going to see all of them. And I even showed you some of them. That is when we're trying to compare several categories at the same time. Right? We'll see that. Now, line charts, like I said, line charts are just they try to show you trend by time. It's only when you need to show trend by time that you use line charts. For example, I want to see the amount of rainfall by date, right? I can use that by time. If you want to see sales by month, you can still use by line charts. It's just that they will not do the real work of line charts then. If you want to see sales by week of the year, very, very good, very, very good use case of what line chart. They show trend. They show you how things are either going up or down. Right? That's when you use a line chart. And the difference between a line chart and an area chart is an area chart has a shading here. A line chart is just a line, right? It does not have this shading. That is the only difference between them. And when you want to implement, you can use SNS. That is SNS is Seaborn. Sorry, I didn't tell you that. We import Seaborn as SNS. And that is how we do it. You can just import your Seaborn as SB. When I started, it was very, very annoying and infuriating. Those are the same words, right? They were very, very infuriating. So I didn't I didn't actually have the time to go through, how do I even put it? To be importing SNS. I was not importing SNS, Seaborn as SNS. I was importing Seaborn as SB because it made sense. Seaborn, SB. But in Python community, they mostly call it SNS, and I'm like, okay, is there any library that is called SB that I don't know? But I mean, you can use any alias name you want. I mean, just know if it sounded awkward, it's not only you that is sounding awkward, right? So of course, SNS is what we generally import Seaborn as, and of course, you can use sns.lineplot or px.area. And if you want to convert a line plot to an area chart, you just need to pass area, I think. Or is it field? There is one argument, I think, in line plot. I think it should be area or field. You just pass it in as true. It will just shade. Or is it shade area? Something like that. We'll just see it when we get there. And when you do px.area, it will automatically create an area plot. But we also have px.line. We have px.line. So you can use px.line and also create an area chart from it. Yeah. So the next one is the histogram.
Histogram, very, very important. And you can see histogram, all of you saw how we use histogram to check each, like distribution of numerical columns, like age column, scores column, right? It tries to break your data into several groups, and then it tries to check, okay, which group has the highest representation, right? It's better than plotting each individual value on a bar chart. If you plot each individual value in a bar chart, imagine in a case where you have 50 different numerical values and you want to plot their bar charts, it will make your work look too much. I mean, imagine 50 bars, right? So when you now begin to use histograms, what histograms do is that they break them into several parts, right? And then they now, when I mean parts, like I mean depending on range. For example, if you have age from 19, to 45, they're going to pick maybe from 19 to 22, from 22 to 25, from 25 to, that's what histograms helps you to do. So you know where most people are actually concentrated, right? Of course, as you can see here, you can see a lot of examples here, though we cut them. As you can see, cutted examples. You can see here how we have 40 to 60. You always see that the values in the x-axis are what are sorted, right? You can see how this is for age, this is for another age. We have different age plots, and all of these guys are what are histograms, right? So they are not bar charts per se, because they are not used to show how a categorical variable is doing with respect to a quantitative variable. But what they are trying to do is that they're trying to show you the frequency distribution of your numerical data. This time around now, by grouping them, right, according to a range, right? And they try to also show you whether your data is skewed. Those are some of the hard things you might have to start hearing now. Skewness of data now is when your data is not normal. There's what we call normal distribution. I will talk about normal distribution. Okay, let me bring this guy. Now, when we talk about normal distribution, is that when the data is concentrated at one end of the chart more than the other end, then we call it skewness. Normal distribution believes that the data is supposed to be like a bell-shaped curve. Let me try to let's just go online now and check so that you understand what I'm saying. Don't worry, even if we don't do hands-on today, we have tomorrow. Yeah, so this is normal distribution now. This is normal distribution. I wish I can see more. Yeah, so look at this now. I wish this one can open more. Don't think it can. Okay, but I believe you can see this. Let me try to zoom in so some of us using our phones can see. So this is a normal distribution now using a histogram. You can see how the thing is increasing from 700 to 16, right? And you can see how the thing is rising up like a bell-shaped curve. The bell, some of you were not timekeepers when you were in secondary school. Yeah, there is this school I taught. I don't think there was a timekeeper at the particular time, so everybody was rushing to go and ring the bell. So imagine a bell lying down, I mean, face down to the floor, right? I know there is supposed to be like a handle here, but just look at this guy now here. Look at it as a bell. So this is a normal distribution, right? Now, so when the tallest bars are by the right here, and then the shortest bars are by the left here, we call this a left skewed. So the skewed is when this is what we call like the tails of this normal distribution here. The tails here. These guys here by the end are what we call the tails of a normal distribution. So when the left tail is longer, as you can see, the tail here and here are the same. When the left tail is longer, we call it a left skewed distribution. And when the right tail is longer, we call it a right skewed distribution. So you can begin to see how complex data distribution can be. Most of us just plotted histograms, but we didn't offer a lot of insights as to what kind of distribution that is, whether it is left skewed or right skewed, or it follows a normal distribution. So I believe now that I'm talking now, you go back to your project and go and look at your distributions and now see whether they are left skewed or right skewed, right? So let me look at skewness of distribution skewness. And don't worry, I tell you this, don't worry. If it means that this is the only thing we're going to do today, just follow me anchorly, right? So that we'll get to that place we want to get to. I'm trying to see. Let me just download this so that I can open it and we can see it. Don't want to visit this site. Okay, it's actually refusing to open. Okay, it's not coming up. Cancel, please. Okay, oops, that's not the best image I've seen today, though. But this will do. Should do. Okay, I believe you can see it, right? Let me know if you can see this image that I have here. Hello, can you see what I have here? Okay, so you can see this is we call it a positive or a right skewed graph. This is a negative or a left skewed graph. And why would this be positive? Is because maybe possibly because the values are more concentrated towards the left, you know, and here they are most concentrated towards the right. You know that these are statistical jargons, but that you need to also understand. It helps you make decisions better as a data analyst, right? So in another concept that this image is now showing us is that in normal distribution, this is a normal distribution or symmetrical distribution, if you like. All of them are normal distributions, but this is symmetrical. Now, is when the mean, the mode, and the median are the same, are in the same place. When the mean, the mode, and the median are the same, or at least very, very close, so much so that the differences are negligible, then we say that the distribution is a normal distribution, right? And you find out that in most data sets that Kaggle will give you find out that the mean, the mode, and the median will be close to each other, right? So that distribution follows a normal distribution. Even if you plot it on the graph, you see that it follows this bell-shaped curve. But when now you can see when the median will always be in the middle, of course. Now when it's the mode, the median is between the mode and the median. Like, sorry, when the median is between the mode and the mean, then we call it what, a left skewed graph. Of course, even if you don't understand this, if you plot it, you see it. And then when the median now is between the mean and the mode, that here you can see the mode came first, is by the left, and the mean is by the right. That means the mean is greater than the mode. Because of course, if these values are arranged, they are arranged in increasing order. So if the mean is greater than the mode, that means that um, the distribution will be what? Will be left skewed. But if the mean is less than the mode, then it means that the distribution will be what? Will be, sorry, I take that again. When the mean is greater than the mode, it means that the distribution will be what? Will be right skewed. It means most of the values will be towards the left. When we mean right skewed, it's the tail that determines where it is skewed to, right? If the tail is by the right, I mean, if the longer tail is by the right, it means it is right skewed, right? Here, the guys are the same. So we call this a symmetrical distribution. But by this side of things, right? By this side of things, this distribution is looking where the mode is greater than the mean itself, then this is a left skewed graph or a negative skew, right? So both this guy and this guy are non-symmetrical, but this guy is symmetrical. And if you're a math student, you understand what we mean by symmetry. When we say a line of symmetry, it's a line that divides a shape into two equal and identical parts. And that's why you're seeing this line here. You can see that if you cut this guy like this into two, you find out that each of these parts look identical. But if you cut these guys here, find out that these guys do not look identical. In this case, either way, in this case, there is no way you cut these guys and they will look identical. Each of the parts will look identical. So I'm just trying to say that if you don't understand this, you don't really have to, but you should try to. If you understand what I said. If you don't understand, you can chat me up later. We can actually talk again. My goal is to try to make this as easy as possible for everyone, and I hope I'm doing that. Please, if I'm not doing that, you can just give me a hands up so that I can go back and explain more. Mm. So I'm free to continue, right? Hello, I'm free to continue, right? Can I continue? Okay. Why is the only one person that is telling me that I can continue? Make sure I'm safe in this class. Okay, okay, okay. Glow, are you on this call? Okay. So what I'm saying now is, well, from all we've learned all together today, and you know, before even now, we've been learning how to use tools. But I've always been telling you that data is more of a thinking thing, right, than a doing thing. It's more of a thinking thing, like I said, than a tool thing. So I'm trying to teach you now. This is the part of data analysis that you don't see in YouTube tutorials. Trying to teach you how to think like an analyst and how to know what kind of visual to do, how to interpret visuals. Right? Those are things you don't mostly see in YouTube tutorials. That's why you're paying money for a course like this. So of course, you hear me talk about things like rule of thumb. Rule of thumb is just um, a rule that is set by community of practice, right? So they said choose the bean size carefully. Too few beans hide patterns. Too many create noise. So of course, there are rules to create even these beans. We've not been passing the number of beans we need to create, but I'll teach you how to pass the number of beans rightly, right? I will look up for some. Who will remind me of this one? Glow, remind me of this one when we go to hands-on on histograms. I'll teach you 2 to 3 techniques to choose the right bean size to use, and you see how to dynamically calculate that, right? And how to do it, you can use plt.hist, you can use sns.histplot, you can also use px.hist plot, I think, or histogram or something like that. It will also give you. So all of those visualization libraries, you can still be able to use, you can still be able to create histograms from them, right? So box and whisker plots, very, very important. We didn't see these guys. These guys are supposed to be next to what you call histograms, are supposed to be next to histograms. This one, the idea about them is to show us some very, very nice things, like some very, very nice things like the histogram will show us whether the distribution is skewed or not. But a box plot will show us a box here, as you can see. We call it box and whisker plots most of the times. So a box plot will show us a box, and the first there are 5 things that this box and whisker plot is showing us. The first thing it shows you is the minimum value and the maximum value. Those are the first 2 things you see, minimum and the maximum. Then it shows you the first quartile, which is otherwise the 25th percentile. It shows you the upper quartile. This is the lower quartile, this is the upper quartile, right? Q1 and Q3, which is the 70th, but the Q3 is the 75th percentile. It also shows you the median value. In one plot, it will show you the median, right? You see the median, the first quartile, the second quartile, and the minimum and the maximum in one plot at the same time. And the beautiful thing about box plots, why most people use it, is because it helps us to identify um, outliers. Outliers. So outliers are basically, some of us spoke about outliers during their presentations, and I enjoyed. Right? We spoke about outliers. Who can tell us something about outliers? Buchi, tell us something about outliers. Blue, tell us something about outliers. Let it not be like I'm talking like one megaphone. Let me calm down so that somebody will teach me. Hello? Yes, I can hear you now. Okay. Okay. So, I mean, you don't have to do it in your assignment actually to tell us. You know why I always call you? Because you're a, you're a statistician, that's why. Okay, yes, Mr. Isaac, sir. Okay, thank you for being that technical. Thank you. So box plots, sorry, outliers are values that fall outside a particular range of numbers, right? And the range of numbers, what governs the range of numbers is what we call, what he said, like our lower threshold and upper threshold, right? So we have the lower threshold and we have the upper threshold, and you saw how we were able to calculate that, right? We were able to calculate that, and of course the whiskers are what we call 1.5 times IQR. You remember? We subtract it from the lower, from 25th percentile, that is lower quartile, and then we add it to the upper quartile, right, to get our whiskers. So any value that is below the lower threshold is flagged as an outlier. Any value that is above the lower threshold is flagged as an outlier, right? So you find out that this minimum now and the maximum are actually your, not your smallest and biggest values, right? They are not actually your biggest and smallest values. They are actually your whiskers. That is the lower and upper threshold. Thank God you can even see it from here. I wish I can zoom in. You can see it. If you get this slide, you see it from here. It's Q1 minus 1.5 times IQR, and this is Q3 plus 1.5 times IQR, right? So you can actually see that from being here, right? So in just one plot, you can be able to see your outliers. You can be able to spot how many values you have that are below the lower threshold and how many values are above the upper threshold without even calculating. You can see them, right? You can see if you have outliers. So forgive me if I stressed you, if I made you check before you computed, but you can use this to confirm that you don't have outliers. Yeah, somebody was going to ask a question. Okay, I thought you had a question, Mr. Isaacson. Okay, okay. Right, so let's go ahead today. Like I said, these are the whisker plots. So the dots you're seeing here, they represent outliers, right? Data outliers, and of course, we've spoken about how to calculate outliers, but we will see box and whisker plots and what they do. All of these ones, we'll see them hands-on, right? And we have scatter plots. So scatter plots help us to see whether there is a relationship between two numerical coefficients, numerical variables. For example, let's talk about um, what do you call them? Age and score of students. We'll try to see maybe if there is any correlation. We call it correlation, really, or any relationship. Let me try to run away from the grammar. If there is any relationship between any two variables. And one of the ways to check that relationship is to use correlations. And scatter plots help us to visually see whether there is a strong correlation or a relationship. Correlation just means a relationship between any two numerical variables. That is what correlation means. Correlate, right? Not cohabit, to correlate. So between two numerical variables, I mean variables like age and score, variables like age and you know all those other variables that are numerically in nature. I mean, I wish I can mention some of them now. Sometimes when I start this class now, they just begin to disappear. Right. So you can see it here. When you plot them, each of these dots represent a particular plotting. So here, maybe at maybe 10 and 63, you can see a plot. When this is, when the age is, maybe when the age is 10, the score is 25. This is body mass index. I think this is a BMI plot. Maybe age and BMI plot. Maybe, so when the age is maybe 10, the BMI is this. When the age is this, up until this guy that we have here. So why I'm telling you this, I will talk more about scatter plots. Maybe when we begin to visualize them and we begin to see. But then, like I said, use the scatter plot to determine if a variable A affects B or if they have any relationship between them. That is what we try to see. Now, if a variable is very, very strong, I mean, the correlation can be in two directions. There's what we call a positive correlation and a negative correlation, right? A positive correlation is a case where an increase in one variable automatically affects or causes an increase in another variable. For example, now age now and I don't want to say education level because it's categorical. age now, and maybe height, age and height. I know that that is not going to be a perfect correlation, but whether you like it or not, the age directly affects the height of a person because you grow with your age. Even though I know some people, when it gets to a particular point, it's like this will halt and mark down, at that particular place, and they will tell you that they will not move again. This is very good. But nobody ever grows with a stops growing with a baby height. Even dwarfs, they outgrow baby height. Like baby height is the height that a normal baby is giving birth to. I don't think even dwarfs have baby height. Right. So what I'm saying is that um, there is going to be a good relationship between the age of people and their height. Right? Maybe not so much between height and age and weight, but age and height, there is supposed to be some kind of positive relationship. So an increase in age causes an increase in height, right? So when you have that, then we call it a positive correlation, where an increase in one variable causes an increase in the other. But when an increase in one causes a decrease in another, right? When an increase in one causes a decrease in another, then we call it a negative correlation. And it's still a correlation. Very, very strong one, but we call it negative. That is when you begin to see that your correlation values, some of them have positive values and some of them have negative, right? So strong correlation, a correlation value is between -1 and +1. For positive correlations, they are between 0 and 1. For positive correlations, they are between 0 and 1. So the more the value is closer to 1, it shows increase in positivity. It shows how, if a correlation of 0.9, right, is stronger than the correlation of 0.3 or 0.4, right? So when you see 0.9 is high correlation, don't worry, we're going to see that correlation. We're going to see how to plot it later on. I'm just trying to explain to you all of these guys now. So when we have a correlation of 0.9, it's very, very high. When we have a correlation of, say, 0.3, 0.4, then we can say it's a low positive correlation. Similarly, in the negative direction, it's also the same. It moves closer. The more the correlation moves to -1, it shows strong negative correlation. Right? Strong negative. When you have a correlation of 1, it means perfect correlation. When you have, but you rarely will get that though. So when you have -1, it shows a perfect negative correlation. So as the values move from 0 to -1, right, it shows increase in increased strength in the negative direction. That is, an increase in one causes a decrease in the other. And what example could that be? I'm lost for example. For lack of examples now, I would like to say maybe increase in age causes a decrease in the time spent on social media, right? So if you're trying to measure the time people spend on social media, the number of hours they spend, you may mostly find out that with an increase in age, maybe because of responsibilities and other things, there is an increase, there is a reduced amount of time spent on social media, right? That is for lack of examples. I don't even know how to say this better now, but I wish I could find better examples that can explain that. So those are what shows negative correlation. And you can be surprised that there are some guys in your data that are showing very, very strong positive or negative correlation. And you should watch out for those so that you can be able to tell your supervisor, I found out something that is driving our sales. For example, if you are trying to check variables and sales, you can be able to check what variables have high correlation with the sales. And then you can be able to, like, if we can be able to increase this, it will be able to increase our sales. This an increase in this reduces our sales. So if we can be able to reduce this, because if an increase in this variable reduces this variable, it means that if we reduce this variable, it will increase the other variable. I don't know if I'm making sense. So if I have age, like I mentioned, age and what do you call them now? Age and the amount of time spent on social media, right? If we notice that an increase in age correlates with an, so negatively with the amount of time spent on social media, we can actually decide to do this, right? We can actually decide to market more to younger people. We can decide to say maybe it's because we are marketing more to, maybe if our stuff is more social media stuff, we can decide to say, okay, let's market more to younger people so that we'll be able to have more engagement or more people staying online, right? So it's more of a thinking thing. Now you can see that the things that you did on your project, there is more to what you should have done. or to the explanation you should have done. But I allowed you to do that so that you have small wins on your presentation. And those small wins, they have the ability to, help your curiosity and your creativity going forward. So if you want to plot it, of course, you can use SNS or scatter plots, plotting passing your x and your y variables, or you can do SNS.reg plot. Very, very important. We will see this reg plot. This regression plot will also calculate the regression. We will also carry out the regression and plot in a regression line for you. You will see that. Don't worry. We will see that when we go for hands-on. Then we have a heat map. I think this is our last slide, if I'm not mistaken. We have a heat map. Now, a heat map, what it does is that it tries to show us, you remember what I talked about scatter plots, when we calculate correlations. So when we calculate correlations, in Python, we can calculate correlation in just one line of code. You don't need plenty of lines of code to be able to calculate correlations in Python. So you can calculate correlations in one line of code. And so because we can do that, we can leverage on that advantage to be able to plot our scatter plot. Now you can see that in this scatter plot that we are, heat map, the values here are between 0, -1, and 1. You check now. There is no value that is below -1, and there is no value that is higher than 1. Check, right? And you can see that where we have these blue guys, don't worry, when we come to heat maps, a correlation between any variable and itself will be perfect now. I don't know if you understand what I'm saying. If we are calculating a correlation between age and age again, of course it will be perfect. Because the age is the same thing you're trying to calculate correlation between, right? So it will be perfect correlation. And that is why these guys you're seeing, the diagonals are always 1, 1, 1, 1, 1. It's because these are the correlation of each variable and itself. Maybe let's say this heat map is not correct, but this is variable 1, and this is another variable 1. So when you're correcting variable 1 and variable 1, it will give you, of course, the perfect correlation. But this is between variable 1 and variable 2 here. This is it's not showing us completely. I would have loved you to see this. So it's showing us a correlation between variable 1 and variable 2. So you can see that there is a high correlation between variable 1 and variable 2, right? And you can also see it here. This is also showing us variable 1 and variable 2. So you see that we have also a very, very strong correlation. So who can tell me where we have another strong correlation here by looking at this plot? Tell me where we have another very, very strong correlation. As you can see, the heat map, what it tries to do is that it tries to color the correlation so that you can be able to spot the happening places easily and ignore the non happening places. Because sometimes you can be confused between 0.1 and -1, right? So it tries to color them so that you can be able to easily see the happening places. I'm trying to say the happening places where there is some reasonable correlation. So who can tell me where there is another reasonable correlation again? Okay, 0.79, right? Okay, 0.97. Yeah, we already spoke about this. But of course, you can look at this one now. You can see 0.79. Now, as you can see here, this is a variable. This is between variable 1, 2, 3, variable 3 and variable 4. So it means there is a strong negative correlation between variable 3 and variable 4. It means that an increase in variable 3 will decrease variable 4, and consequently, an increase in variable 4 will decrease variable 4, right? So these guys now are trying to show us, right, in just a heat map. That's why it's good to show a heat map. You don't have to explain anything to anybody. They can easily be able to spot the happening places easily, right? Like we did here, we were able to spot this one here, right? And we're able to spot this one here. So it will show us the happening places easily. And that is what a heat map does. It shows us negative and positive correlations. And this one is applied in AI, in machine learning, for us to know which variables are highly correlated with whatever variable we're going to use for further analysis, right? It helps us to also know whether, if somebody is trying to argue that there is no difference between the age of students does not affect their scores. You can collect age of students and their scores, bring it, plot a heat map, or you can plot the heat map of just two variables, or find the correlation, see the value of the correlation, and then you can argue your case from there. No, don't argue cases without proof, and your proof is in your data, right? Don't argue your cases without proof. So if anybody is trying to tell you tell him bring data. It's data that we can use to show. If you don't have data, you're just another man with another opinion. But with data, you have evidence, right? Okay. So, okay, sorry. This is what heat map does for us, and we're going to see that heat map and how to get that done. So if you want to get heat map, you can use sns.heatmap. I think even Plotly has heat map. Matplotlib also has heat map. So all of them have heat map. Now you can see all of the charts we've seen earlier from the beginning, right? It's only red plots that Matplotlib does not have, but all of them have these plots. So you can only choose the one that you're more conversant with, right? So let nobody pressure you and make you feel like I don't know how to use. You don't know how to use Seaborn. That you don't know the tools. But it's not Seaborn that makes you a data analyst. Is that you are able to use it to analyze data effectively. Of course, Seaborn makes the work more easier for you in that you don't need to bring, you don't need to do pivot tables, right? But still, in your analysis, you will need to do pivot tables to show your data in tabular form for people who want to see tables, right? But then, if you want to just plot the guys directly, you can go ahead and use Seaborn, right? So heat maps, like I said, they show you the happening places. That is why it's called heats. Shows you hot spots or things you should look at. And you can see it's color-grading them. Don't worry, you see all of these ones in code. And this df.core, this guy that you're seeing here, if you use df.core now on your data, it will calculate the correlation between all numerical variables. That is what you're seeing here. Then if you pass the values here, it will return it like a matrix. So if you pass in the values inside the sns.heatmap, it creates like a heat map like this. And then if you pass a not equals to true, this a not equal to true is what passes these values inside. If you don't pass a not equal to true, it will just give you colors. Don't worry, we'll see all of this. I don't like saying a lot, but of course with this slide, you can go ahead of me already. Somebody was sharing with me today that she enjoyed today's webinar that we just had now on KPIs because she went ahead to learn some things before the class started. So you can also go ahead to learn some things before the class starts, right? So now what kind of visual should you use, right? What kind of visualization tool should you use? Like I always say, it depends on you, depends on the use case, and it also depends on whether you want to do flare stuff, right? So Plotly is a high impact interactivity. Use Plotly, right? Like I say, interactivity, it can allow you do things like there's what called slicing and filtering. It will allow you use slicing and filtering. You can also hover around the charts and you can also see your data changing, right? You see all of that. That is why we should use Plotly, right? When you want to see, when you want to see, what do you call it now? When you want to see how your data is changing, I mean when you want to hover around your data and be seeing the different values or some further information about your data, you can now bring in what you can now use your Plotly. If you like styling, you can see tooltips, right? Dynamic zoom in, of course, it will zoom in and adjust as if you reduce the size of your notebook, it will adjust dynamically, right? It will dynamically fill your screen. You don't have to be using plt.figure or fixed size to be adjusting the size. It will dynamically shift for you. That is why you should use what do you call Plotly. And of course, toggleable legends. That is what we use for the filtering. You see that in most of my analysis going forward, you see me using Plotly most. I like Plotly and maybe Seaborn. You hardly see me using Matplotlib again. Not because I don't like it, but I mean, I just kind of find Plotly interactive. But I'm not saying that you should also choose what I'm using. You can go ahead and use Seaborn or Matplotlib or other visualization libraries. I think we have many of them out there, right? You can choose any of them. Now, this table is not very, very visible, and I wish it was. Let me see if I can do something about that. I had no idea this table was not visible. Let me change the text color. Sorry about that. I think it's a bit visible now. So this is just trying to compare these libraries and trying to show you which one you should use per time, right? And don't worry, we are almost done. We are wrapping up our class. Our class today is just going to be theoretical. Then tomorrow we will do the hands-on. For every of these visuals that we spoke about, we're going to see them. We're going to keep a data set, try to plot them with all of these visualization libraries that we spoke about. I'll just talk about one and pass. Then you can go and do the rest by yourself. And I'll also give you exercises to go and try during the weekend. Plot all of those kinds of visuals. That's just the only thing you do. Next week when we meet, I think we might try to look at time series analysis. Very, very easy. You've also done things around time, but we're going to see when we have time data, how to handle time related data, how to do line plots. We'll see more about line plots next week. And then week after next, we will now round up with, oh boy, we still have some things to cover. I don't know. I think as the work continues to go, so that we keep to our time, we might be having some midweek sessions. I beg. I think this time series we might have it during midweek. If I give you this one, since this one is not much of a work to do, right? You already know it. I think we'll have a midweek session, maybe around Thursday or Wednesday, to discuss time series. And then when you're done with that, so that next weekend we can just look at our SQL, right? We can start SQL and see SQL Python combo. So that after that, we'll just wrap up with presentation skills, and then you can already build on your capstone projects. So I actually like your capstone projects, and we're going to create a form so that you submit your capstone projects. And when you do so, we will try to advise you on whether to continue with it for your capstone project. I mean the mid project, sorry. We'll advise you whether to use it for your capstone or to start preparing. It's now that you're supposed to start preparing for your capstone project. Know what you're supposed to do. Dream of what you want to analyze. Collect real-world data. You had the emphasis was on real-world data. Anybody that use data from Kaggle, they don't even read your analysis again. And if your capstone is not on real-world analysis, people think you're not serious. But once you carry out the real-world analysis, if you go out, in fact, you can use that to get the job. Okay. No, capstone project is you that will choose what you will do, sir. It's you that will choose the topic, just like you did for your project on, I think, CS bar. CS rates. So that's how you do it. You are going to choose a topic, collect the data. For example, you now, I think they advise you to, capstone is the project you do at the end of taking a course. I don't know if that is understood now. Capstone is the project you do at the end of taking a course. Every course is just like your final year project in school. That is what we call capstone. CAPSTONE. Cap, hula, stone, duty, capstone projects, right? So more like to capital. That is what we mean, to capital. So let me take it again. You look for a real world project, like just like all of you, most of you here took real world projects. So take another one that is bigger than what you did earlier. For example, if the data you collected earlier, they gave you advice on including some kind of analysis and making your data set large, you can then go ahead, send your questionnaire out again for multiple people to fill it up for you, and then you can make sure you have a statistically significant number of what do you call them, of responses. For example, we advise that for statistical significance, you should be able to have data that is not less than the sample size. And I taught you how to calculate sample size. If you forgot, go back and check your previous videos, or just Google it online, how to calculate sample size. Use the Cochrane's formula to calculate your sample size. You can see that the things you learned in week 1 are still relevant to today. They are still very, very relevant. So learn how to calculate your sample size. And if you're using Kaduna State, you find out that the sample size in Kaduna State is around 390 something or 370 something, something like that. So if you can calculate, if you can collect data up to like 400 people, let it not be below that threshold. So that in your capstone now, you're telling people that you collected data that is up to this so number of responses. And this is statistically significant looking at your population, right? That is what a capstone should be. It should be something that when you're presenting, somebody will be like, this person don't learn something. So that's how I want you to present that day. Remember, you're not just selling my analytics, you're selling yourself as well, right? Of course, I'm going to invite some people from outside to come. They might just say, okay, I can see your work and I like your work. I need you to work with you. You're selling yourself out there, right? So sell yourself. Build something that can sell you out. That's just what I'm saying. Don't just build because everybody else is building. Build something that can sell you out. Then let me just wrap up before you people will make me say the things I'm not supposed to say. So these are a comparative analysis of Seaborn and Matplotlib and Plotly Express. So Matplotlib is low level, of course, is low level. This Seaborn is mid level. High level is high level. Sorry, Plotly is high level, not on difficulty really. But when we mean high level is in Matplotlib, you have to it is low level because you have to create group by or pivot table, right? You have to create your group by. After you create your group by, before you now come and use Matplotlib to plot. In Seaborn is mid level. You can just pass in the name of the columns and the data. It will automatically do the, the group by for you and then plot the charts for you. In but then in Seaborn, you still have to add some certain lines of code, you know, to be able to get some things done. But in Plotly Express, in one line of code, you get your visuals. Most at times, it's one line of code that you need, right? Then for default styling, in Matplotlib, is in Pandas, it is the default for plotting stuff. Matplotlib is the default. Seaborn is more polished and a bit modern. Then Plotly Express is web ready and sleek, right? Web ready. When we say web ready, is that you can use it on websites. It is easily dynamic. When I say dynamic now, it means you can see that there are some things that when you do on your when you open a website on your phone, the view changes dynamically than when you're opening it on your PC. So that is what we mean by dynamism. So Plotly is highly, is web ready, and of course, as you can see, it's fully dynamic. While Matplotlib and Seaborn are never dynamic; they are static. You have to control the size of the plot and anything. But Seaborn is highly dynamic, and you're going to see that. Then integration, statistical integration. In Matplotlib, you have to do manual integration, manual calculation. In Seaborn, it is it has built-in descriptions inside of it. In Seaborn, it is built for statisticians, right? In the Plotly Express, I don't know if Plotly has more statistical features than Seaborn. I think Seaborn wins when it comes to statistical stuff. I think Seaborn wins. But at the same time, do not underestimate Plotly. Do never underestimate Plotly chat, right? All right. So 5 golden rules for Python visualizations, right? Labels are non-negotiable. Use labels. Anywhere you have pie chart or labels, Seaborn or labels, the only places where you might not do a lot of labels. In fact, everywhere you have to do label. Label your axis. You had them see it, right? Label your axis, your X label, your Y label, label them. Title your charts. Your bars, like you can see here, your bars should also have labels here. It's not just labeling these guys, but your bars here should also have labels. They are non-negotiable. Then choose color with intent. Don't just choose any random color. I was teaching some of my students. I was telling them that there are colors for color blind people. It's not just every color that you feel you want to use. For example, I saw some of you using gray color on white. I'm like, this person does not understand that there are people who have vision, they have vision impairment. They don't see well. So you have to put colors that will stand out on the background. If you're using a white background if your chart is on a white background, let the color not be something like a sky blue color. Let it be deep blue or black or some color that will stand out. Don't use colors that will stand against you in the cutoff flow, right? And your colors, don't do color riots. Don't do color riots. Some of us here are ladies, you know how to do makeup. Don't do color riots, please, I beg you. Then declutter your charts. Declutter your charts. When I mean declutter, remove unnecessary details in your charts. Perfection in visualization is achieved, not when, let me say this now, and if you need to write it down, write it down. Perfection in design or in anything is not achieved when there is nothing more to add. No, it's achieved when there is nothing more to remove, right? So that is what perfection is. If you keep on adding things, they will add extra information to your chart. But only add the relevant things that are needed for your charts. Make your charts very, very clean as possible. If you don't even need to add some labels, don't add them. But like I said, they are non-negotiable. So only add the information that is relevant to your charts. Stop adding extra noise to your charts, right? And then, of course, He said SNS.dspine, I think dspine. I think it will remove unnecessary grid lines, of course. You can don't add grid lines if you don't need them, of course. Things like grid lines, remove them. Now know your audience. If you're going to go and visualize it and know your audience. If you're going to present to experts, there is a way we present to experts, and there's also a way we present to general audience. So know your audience, very, very important. Know your audience. Very, very what? Important. If you're going to present to a general audience, I mean, make sure that your English and even your charts look general audience. Stick to simple charts like bar charts, pie charts, and the rest. When you're going to speak to statistical people, you can now bring in your scatter plots. They will understand it. A mere man on the roadside will not understand scatter plots. He will not understand skewness, right? So even when you're presenting, you don't have to mention some of those things. You can just, or maybe the scatter plots will come, but maybe small, maybe one or two scatter plots. It's okay. But when you're presenting to high level, you can add the scatter plots in addition to the pie charts and bar charts. You can add those scatter plots, heat maps, all of those. They make sense now to them. They are now seeing things that are relating with them, right? Yeah. So focus on insights. Use annotations to point to most important things. You will see annotations. I'm not sure if we will see that here. Those are pretty advanced, but we'll see them. Focus on main things. For example, now the top selling category, if you can make it, if you can change the color of the bar so that the bar stands out, is fine, right? So that it shows that this is the top performing bar or something, right? Top performing month, the top month we sold most, let it show, right? So focus more on insight as you're telling your story, not on the junk. That is why you need to declutter your chart so that the focus will not be on the unnecessary details, but it will be on the insight that is generated, right? So of course, here's a roadmap for you if you're interested. Learn Matplotlib. You already learned Matplotlib last, of course, previously. Then you watch Seaborn. Now we see Seaborn. We're going to see Seaborn. I'm going to teach you Seaborn and Plotly Express at the same time. Then when you're done, you can now begin to look at Streamlit or Dash to build dashboards, right? We can see one of us, Mr. Taiwo, was able to build a dashboard with Streamlit. No promises, but towards the end of this course, we're going to see how we can be able to do that, right? So I'll ask you if you have any questions for me before I take my leave. So it's like today we did a data visualization webinar. Subsequently, we might have a webinar like this on data visualization, storytelling with data. Well, we'll organize something like this. But if you have questions for me, please ask before we call it a day.